Well, good morning. It is still May 26th. I got a question from a commenter on a video about different ways, best, most efficient ways to hook up a battery to an inverter and put it to work. Here you go, girls. Yep. There you go. You can fight over that. Well, that's a bigger answer than I wanted to type out in the comments. I'm in the middle of, as usual, in the middle of a million projects. Constantly. I'm doing a tune-up on that, tune-up on this, exhaust, patch up, and... So, how to hook up a battery to an inverter of this caliber, 2000 watt pure sine inverter. This is a very simple setup right here. This is a parallel. So I just got two double zero gauge jumper wires, you know, negative, negative, positive, and then the inverter I've got coming from opposite corners, so the power has to move, you know, the amperage has to move all the way through the system. It would actually draw on it if I hook this one to this battery. It would, if you didn't know any better, you know, most people would think, oh, what's the big deal? Well, all the charging, you know, you can see how I've got everything distributed. I have my charging on the opposite posts. So the charging comes in and goes all the way through every single cell. The load goes all the way through in every single cell from the opposite direction. And if you don't do that, if I had all of these tied to just these two, this battery would take all the load and all the charge, and this one would just kind of sit here and slowly drain power back to this one, you know, equalize when the load came off. So that's why you do it that way. So it keeps the electrons moving all the way through the entire system, so all of the cells are being charged and loaded equally. This is a 2-battery system, and that's pretty much as simple as it gets. If you only had 1 battery, then you wouldn't have these links, and yeah, negative would be negative, positive would be positive. Let's go take a look at my absolutely ridiculous bank in the basement. And yes, there's more projects down here. So yes, there's going to be more of a mess. Yeah, just shit everywhere. Sorry. He doesn't mind. Him either. So, yeah, bear it up. I know it's terrible to terrible habits to have tools on top of your battery bank. So this is a 24 volt battery bank, and you can see there's 8 of 2 different kinds of batteries. These are 6 volt. These are 12 volt. So I turn these into 12 volt by seriesing them. This is a series right here. This is a 12 volt battery, 12 volt battery. You run negative, positive, negative, positive. You link the negative to the positive and then test between these 2 terminals, and that's 24 volts. So each one of these, negative or positive, negative, positive, positive, negative, positive, so on, they're all paralleled with equal length wires to my bus bars, which run to the inverter. These are 6 volt batteries, so it's a little bit more complex of a series. Positive, negative, positive, negative, positive, negative, positive, negative. And this, between this one and this one, is what runs to the bus bar. So this whole block, it takes all 4 of these batteries to make 24 volts, all 4 of these batteries to make 24 volts. So it's a series parallel between the 2 of them. This is all a series parallel. Series paralleled into the bus bars, and I'll show just for kicks. You know, they all just link up there. And I've got every single cable going to the bus bars is equal length. I got a whole reel of, this is 0 gauge wire, and then I got 00 on the jumpers, 00 on the leads going to the inverter, because always go overkill on the wire. That's where you build up heat, and that's how you burn down houses, is skimping, cheaping out on the wire. Get copper heavy wire. Always get, you know, just guess double what you actually need. Everything here is, you know, scaled up, ridiculous, heavier than it needs to be. But you know, if you want an efficient way to charge and discharge, get all the potential energy your inverter can put out, heavy wire and hook it up right, man. Clean up your connections, keep an eye out for, you know, corrosion spots, like, see it? Oh gosh, I keep battery cleaner spray right here, and a couple times a year I hose down the entire thing, all the connectors, just the entire thing, and then come behind with clean water and pour it over. And fortunately there's a drain right there, so all I got to do is move my overpriced guitar pedal and my, you know, move a couple things, and it's not a big deal. We live off of this. We require this to work, so I do what needs to be done to make it work. I put it on a plastic surface. I added the plywood there just to help keep everything flat and level, because it actually helps to have your batteries level, because if they're tipping, you can have cells that have, if the water is tipping too much in one direction, you might have some cell material exposed. And if air touches those, it'll start to sulfuriate really fast and degrade. And you got, 1 out of 6 cells dying. Well, that's gonna act as a load. It's gonna start to ground itself out, and it's gonna act as a load on the rest of the battery. And it'll generate heat, and it'll eventually turn into potentially a dangerous problem. So yeah, that's all I got. Proper battery connections. If you're going to be running some power, equal length cables, and gauge your wire up. Good copper connections, crimp them, you shouldn't have any problems, man. You should be able to run whatever you need. All right. Thanks for watching. God bless you.